Hello class, so this is going to be a video of just solving the problems in the week 12 lab assignment. Hopefully once you see it you'll have no doubt as to how to complete your homeworks. Let's start with question 1. You have samples of n1 equals 25 plus n2 equals 21 and you are performing a pooled variance test. How many degrees of freedom do you have? Well, it's n1 plus n2 minus 2. That's 46 minus 2, 44. Problem 2. Assume you had a sample of n1 equals 9. Sample mean is x bar equals 45. Here, let me do this. n1 equals 9. x1 equals 45. Sample standard deviation, S1, is 4. And then we get an n2, an x2 bar, and an s2. So this is clearly a two-sample test. They're asking for a pooled variance test statistic. Rather than looking into the tables, let me just go into the right template. Where's my template? It's down here. I need to find the two-sample one with pooled variance. There it is, pooled variance sample. Okay.
The first sample size is 9, second sample size, the x bar is 45, the s1 equals 4, 17, x bar is 34, and 8.
Okay, so I've punched in n1 x bar 1 s1 and n2 x bar 2 x2, 945, 4, 17, 34, 8. The test statistic is 3.8515. They're asking for 4 decimal places. How many degrees of freedom are there? We already did that. So it's 9 plus 17 minus 2, so 26 minus 2, 24. But if you didn't know that, it's written right here, 24. Using alpha equals 0.025. What is the critical value of a one-tailed test? Okay, wait a second, now we're doing a one-tailed test. So not here, but here, or maybe here. Is it an upper tail or a lower tail test? Let's look at H1. H1 points to the right, that's an upper tail. I put in all of the values. Sorry, I got this one wrong. That's 9. 9, 45, 4, 17, 34, and 8. Critical value is right here with 4 decimal places. Statistical decision. It's written out here. Our p-value is really low. We can reject the null. So it's one of these two. And of course, it's because the t statistic is higher than the critical value. Remember what this is supposed to look like. On the upper tail, you got to reach beyond the upper critical value. An experimental design for a paired t-test has 18 pairs of identical twins. Has 18 pairs of identical twins. Okay, that's going to be a paired test because we can pair the twins. How many degrees of freedom? Remember, a paired test boils down to a single sample test after you've taken the difference. So this is going to be 17. Well done. All right, question 4. We have 9 experts that rated 2 brands of coffee in a taste testing experiment. We've already done this before. You remember how it goes. We need to do a test. So first of all, what kind of test is it going to be? It's going to be a paired test. I already selected this out here. All I need to do is fill in these values. But where do I get the values? Let me get the data first. It's this data. Let me open it in Excel. Here's my data. Let me zoom in on it. Okay, remember what I got to do here? I got to take the difference, A minus B. Okay, and take it, I drag it out, and then I get the mean, the standard deviation, and the count. Here it's only 9, it's easy to count, but if you had more data, you can just do it this way. All right, let me just copy these values. Okay, so I'll just paste the values right here so I can read them off easily. The level of significance should be 0.1. The sample size should be 9. I still have that because I did it last time. Now the mean and standard deviation, I just read them off. Okay, but first things first, what are the alternative hypotheses? Well, this doesn't work because we should have an equality sign. These and these don't work because they're asking for a difference not greater than or less than. The t statistic is minus 3.0431. They only want 2 decimals. Critical values are right here. The test statistic does not fall between these 2 values. We reject. There is sufficient evidence. What assumption is necessary about the population in order to perform this test? Well, it's always about normality. We need to assume that the measurements are approximately normal. What is the p-value? Right there. And finally, the p-value's probability of obtaining something like this, at least as extreme as that, if H1 was actually satisfied. 95% confidence interval, we can read it right there. Minus 233, minus 0.56. There we go. Okay, question 5. N1 equals 50, N2 equals 50, X1 equals 10, X2 equals 10. And we need a 10% test of significance. However, these are pi's. So this is going to be about proportions. We need a proportions test. So I already know this is what I'll be looking at. Looking for a significant difference, it's not a less than or a greater than. It's definitely not a non-equal as. So it's going to be right here, equals. Calculate the z-stat based on the difference P1 minus P2. Let me punch those numbers into here. Okay, and now I can read the z-stat, the critical values, the p-value, and anything they ask me for. They're asking for 3 decimals, so even though this is the same number, I'm just going to make sure I only put 3 zeros in here. Obviously, with a p-value that low, we reject. 90% confidence interval, that's still the same alpha, so we can just read the values from here. They want 4 decimal places, so let's get these values. There they are. Okay, question 6. Again, we have 2 samples. We get an N1 and S1 squared, an N2 and S2 squared. And we are testing a null hypothesis. Sigma 1 squared equals sigma 2 squared. Now they're already telling us that they are testing sigma 1 squared equals sigma 2 squared, and they give us the f-stat. Now we know what this is for. This is to check whether sigma 1 is equal to sigma 2. Since the critical value is 2.27 and the f-stat is 1.45, that f-stat falls below the critical value. What does that mean? We fail to reject. So it's one of these two. We fail to reject because we don't have enough evidence to reject, so it's here. Okay, question 7 is going to be the same type. How do I know that? Because we are first testing for the sigmas right here. So we are going to test for the sigmas and determine whether we need pooled variance or separate variance. The manufacturer is comparing type A shingles and type B shingles. We have a first sample for A and a second sample for B. We completely analyze the difference in weights, meaning we're going to first test the variances to figure out whether we need a separate variance test or a pooled variance test. And once we figure out which one we need, we're actually going to do the test. Of course, we're trying to see whether the two variances are equal, so it's this question. Identify the test statistic. We need to look into the table. Okay, we've opened our data. We're going to need the mean, the standard deviation, and the count, as always. Okay, this is the data we have. Let us copy this and paste it out there. Here, let me just paste the values so I can read them off easier. Now, very important, we need this variance to be higher than that variance. So which one are we going to punch in first? B, because 3600 is greater than 3100. Now be careful one thing, this requires the variance. Here you have the standard deviation, so you have to square these. Okay, those are our variances that we just calculated here, squares of the standard deviation. Of course, you also could have just written this. Variance of a sample. And that gives you the same values. Either you square the standard deviation or you just compute the variance. Both work. Coming back to the problem, the test statistic is 3.8501. They want 2 decimal places, 3.85. Okay. P-value for the test is 0. What is the conclusion of the test? The p-value is a low. We reject. It's always because we have sufficient evidence. So the samples are independent. We know that from the text. But there is sufficient evidence to say that the variances are different. Therefore, we use a separate variance test. Different variances, separate variance test to compare the means. By the way, this answer will always be independent unless you are using a paired test. So we're going to use a separate variance test. There it is. What are we doing? We're comparing the means. So we're just going to do an equality test, right? Not inequalities and definitely not unequal. We got to go punch in our data into the two-tailed test, but we already have that. Right here, we computed all of this. Let me copy this again. So the hypothesized difference is 0. We want a alpha equals 0.001. And we got our answers right here. The test statistic is minus 70.37. 2 decimal places. P-value for the test, very low. It's 0.00 again. And of course, with a p-value that low, we reject, and there's always sufficient evidence. Okay, last question. Investment types of mutual funds. This data is the 1-year return for 9 bonds and 9 stocks. And we want to analyze the data. Again, we see that there are sigmas here. So the first thing they want us to do is test the variance. Let us go back to this tab. We're going to be testing this question. Again, we're testing the equality of variance, so it's not this, not this, not that. Because we're doing an F-test to determine whether it can be assumed that the populations have equal variances. So it's this one. Again, we need to get the values out. We just did this before. Be careful, this is a sample, so take var s. Just for good measure, you can check this squared, same value. Let's copy this. And this is the question from before we can ignore. 5% level of significance were there. Sample size is 9. Sample variance is 1786 is the big one. And 5.0795 is the small one. This gives us a test statistic equal to 3.5161, only 2 decimal places. 352. P-value for the test, 0.94. Oh gosh, I put the wrong number of digits again. Okay, good. Be careful with that, even I make the mistake. Of course, this is low, but not as low as 0.05, so we cannot reject. There is not sufficient evidence. In this case, samples are still independent, but there is not sufficient evidence, and so therefore we use a pooled variance test because we cannot say that the variances are different. So we go here and we take the pooled variance test of the mean. Again, we're just looking at a difference, so we are going to check this answer. It's not about greater than or smaller than. We want to check whether they are equal. Let us bring back those values that we here, the numbers punched in. The test statistic is minus 2.57, 2 decimal places. Okay, minus 2.57. P-value for the test. This time I pay attention, 3 decimals. Conclusion for the test. This is low, and it is lower than 0.05. We can reject. When we reject, it's because we have sufficient evidence to do so. Okay, that's it. We did all 8 of our problems. Hopefully you've seen why I did what I did and how these different templates are to be used. If you still have issues or if you don't understand why I did things the way I did them, please just get in touch with me. Hopefully this will help you with your homeworks.